again. So the last presentation in this session is from, well, we had to swap, and therefore it's a bit maybe surprising, but it's from Meenu, who is looking increasingly frustrated with her computer, but I hope you succeed this time around to share your
No,
screen.
actually, I have updated my system today morning. So there is some issues in uploading, like sharing content. So I just send you a mail. If you can just share the screen, I can just start with the presentation. Yeah.
Oh, you want
And
me
sorry
to
for the
share?
inconvenience to everyone in the breakout room. Yeah.
This is going to be a bit of a problem because we are actually presenting from another person's computer. So I will see if I can share on this one, and then we'll see what happens.
Yeah.
Oh, that is not good. That will not fly. What is the, yeah, that is going to be a tricky one. Meenu, it's not easy here.
You can you can upload the PowerPoint into Teams and ask someone else to take control of that.
Yes, currently we are doing a slightly alternative approach, which is, and the name is reporting workshop. Okay, good. So give me a second. We'll try to get you up and running. There's a file called reportingworkshop.pptx.
Maybe I can start with the intro and not waste time. Yeah. Yeah. Hi everyone in the breakout room. My name is Meenu. I'm a PhD student at Malmo University working in close collaboration with Software Center. And today I'm going to present how we can ensure continuous delivery of MLDL models. Like how to ensure, like as we all know, MLOps, it's like, yeah, this, it's, yeah. How we can ensure continuous delivery of MLDL models. So next, yeah, maybe we can request control. Yeah. Yeah. So as we all know, since most of the companies, they are trying to do a transition from more hardware and product based focus to some more focus on digital technologies such as software, data, and AI companies. Most companies, they need to evolve as well as enhance their current systems with new technologies. Thanks to machine learning as well as deep learning technologies, because of the emergence of these technologies, companies are increasingly incorporating these into their embedded systems. But unfortunately, regardless of the level of expertise as well as access to highly professional data scientists and all, as well as most of the previous studies, they also indicate that companies, they struggle a lot to create some well performing models, and this is due to the absence of well established as well as systematic design methods and process. So based on all our longitudinal case studies with companies, as well as when we look through the previous studies, we figure out that there are definitely large number of challenges when it comes to the case of end-to-end process of developing, deploying, and evolving models. So this is a part of Project 41, and the vision is to help embedded system companies to address the different challenges they face while developing, deploying, and evolving these models. And one of the solution is to achieve some systematic and structured design methods, because most of the time it is not only the data scientist who is dealing with the development, deployment, and evolution of MLDL models in companies. Maybe due to some shortage of these experts, maybe some software engineers or people in other roles, they are also forced to do some kind of development, deployment, and evolution. So as part of this project, we studied three primary research questions. One is, what are the different activities activities data practitioners perform, as well as what are the challenges they experience while trying to develop some MLDL companies, some MLDL models that has to be integrated into their entire software intensive system. And another thing can be like what are the different best practices as well as architectural choices that can be chosen by the practitioners when they try to deploy AI models either at the on-premise, edge, or cloud. And third, it is like how the evolution of machine learning operations they can support embedded systems to achieve continuous delivery as well as evolution of models. So towards continuous delivery of ML systems, this is based on case study that we did in 6 of the SC companies, and this has been submitted to Journal of Software Evolution and Process, and it has been recommended for publication with minor revision. So here you can see a AI driven business development cycle. So in this particular cycle, this particular life cycle, this you can view it as a blueprint to how to effectively develop, deploy, as well as evolve your machine learning models. That is part of the entire software intensive system that has a lot of electronic software, everything. So when we did longitudinal case study research as well as some workshops like cross company and company specific workshops as well as meetings, we figure out like when we checked with practitioners, they find a lot of difficulty like how to act, what should be the activities that should follow when we are doing their end-to-end process, what can be the challenges, what exact roles and functions should be involved, and what will be the typical iterations that should be followed so that we can optimize the entire design. So we figured out like there are like 3 high level activities that data scientists as well as other practitioners perform concurrently and parallel in companies to achieve the continuous delivery of ML system. They are business case experimentation, data experimentation, as well as model experimentation. So business case experimentation, it deals with generation as well as validation of business cases that are highly relevant as well as which can provide some profit to the companies. Then once you have a profitable business case up, then you need to collect data. Even though the whole world is praising about large quantity of data available and need for large storage mechanisms, in practice the amount of valuable data that we can use or that we can put as an input to MLDL models is very limited. So then once you have the valid business case, then it is the responsibility to generate data that can fit to the MLDL models. Then you will have to generate the data, then you need to collect it, then you need to explore it to figure out whether there are any interesting patterns in it and all. Then once you have all these, then it is the model experimentation that there you will be choosing some model based on some literature review or some based on your experience, etc. And maybe then you will be doing some tuning with the like some tweaking with the hyperparameter tuning and all, and then you need to deploy it to the model. Even though we see that the business case generation, data exploration, as well as some activities related to models are very important. Likewise, the process of integrating these particular models into the extensive system out there is also very important. In the next slide, you can see some of the iterations, and these are the green ones. They are some of the sub activities that you have already seen in the previous figure. So here we are trying to figure out what could be some typical iteration that can optimize the design model. So for example, maybe if we just look into this particular iteration, that is business case validation to selection and specification of prioritized business case. For instance, maybe when some companies start with a particular business case, they will have some approved metrics for that. That is already approved by the business owners or something. And based on that, the data scientists, they will do everything. And at end, when they want to validate whether their particular model is doing very well, maybe at that particular discussion with the business owner at the very end, maybe they will say, oh, this is not the metric we want, we are just mistaken, we want another metric instead of this to be improved, and all those cases. So in that particular cases, maybe you need to give some priority to some other metric, and you need to do the entire process again. So sometimes it is like it is so wise to stop some business cases that is not yielding any a good profit to the companies itself. Then it is the MLOps framework. As you know, MLOps, it's a practice that will integrate both data scientists as well as machine learning operations to ensure continuous delivery of models. So in this particular work, we did a state of practice as well as state of art to know what is happening in the field of MLOps. This is because MLOps is gaining some popularity nowadays, but most of the companies are at their earlier stages of adopting this to the companies. So in order to advance the understanding of MLOps, we did a literature review as well as validated this in some of the SC companies. So based on the literature review, we figured out that the entire framework, and we need to, when we ask some companies like what do you want to achieve through MLOps, for some it can be reproducible workflow, some it can be automation, for some others they prioritize some versioning, all those. So the entire framework, we can split it into three pipelines. They are data pipeline, modeling pipeline, as well as release pipelines. So it is like first we need to collect data from different sources, and we need to do the data acquisition. We need to pre-process the data so that it will be suitable for the machine learning, deep learning models, and then we need to have the feature engineering. And for consistency as well as in order to reproduce the work, maybe the features we collect, we can store it in the feature store, and once you have the data that is ready to be inputted to the MLDL models, we can store that in the data repository, so that we can use this data repository for other environment or for other experiments and all. And once you have the data, then it is like normal, we need to experiment it with whatever algorithms are best suited or kind of, and we need to optimize it with the hyperparameter tuning, and then we need to evaluate whether our model is best fit to the business model. So once you have then once you have a model that you are trying to deploy into the field, you can just register that in the model registry. And this particular metadata store, it contains all information related to the model. For instance, it can contain information related to the hyperparameter tuning we selected and all those kind of thing. And the code, we can store it in the repository, we can version it so that we can use the code across different environments, and whenever we need to experiment tracking and track some experiments and all those. And once you have a model that is ready to be deployed to the field, then you need to package it, you need to validate it, you need to deploy, and you need to monitor it. And the deployed model, you can store it over here. And the thing is, like whenever there is a problem like model drift or performance degradation occurs, you can initiate the data feedback loop, and you can do the entire things again. So this can somehow automate version or reproduce your entire workflows. And these are 4 stages in which companies evolve when they travel from, or when they try to do a transition from manual process to fully automated process. So the 4 stages in which companies travel through, it's like a stairway to heaven. So the 4 stages are automated data collection, automated model deployment, semi-automated model monitoring, and fully automated model monitoring. So in automated data collection, the companies initially they will be having manual process of collecting data, doing the feature engineering, model experimentation, deployment, etc. And from this particular stage, they want to evolve to automated data collection. In order to emerge to this automated data collection, they need to have mechanisms to aggregate data sources from heterogeneous data. They need to have capability to integrate and process new data sources, some infrastructure for automated data collection, and they need to make sure that same feature implementation that they have used in the training should be used in the inference and all those. And when it comes to the case of automated model deployment, maybe companies, they have manual process of doing the deployment, and with the adoption of MLOps, they want to just transit to the stage of automated model deployment. For in order to reach this particular stage, some of the prerequisites, they can be like the company, they should have mechanisms of automated model deployment, as well as there should be some deployment freedom, like the models, they should be flexible to deploy to either edge, on premise, etc., as well as there should be possibility to track experiments as well as model. And the next one is semi-automated model monitoring. Maybe the companies, they initially have some manual process of monitoring models and all, and with the adoption of MLOps, they need to jump into the semi-automated model monitoring. So there should be some availability of tools for diagnostics, performance monitoring, and addressing model drifts. There should be some mechanisms to look into all the global pipelines using some centralized dashboards, and maybe it's like some automation scripts should be there to manage the entire model in order to monitor the model, etc., etc. And it's once the companies, even though all companies are in the earliest stages of MLOps, everybody wants to drive their company towards the fully automated model monitoring. So in this particular stage, there should be provisions for certification of models, auditing to the usage of the models, as well as some kind of data governance and privacy control. Everything should be maintained. And when we come to futures research, since we have all kind of prototypes, like how to ensure continuous delivery of model, what are we investigated on, what are the different activities, challenges, experience, and everything. Now we are trying to figure out, like based on a follow-up study we did on Tetra Pak, it's kind of, we generated 5 architectural alternatives to deploy MLDL models into the edge, and based on that, as well as which we have validated in some of the SC companies, we are trying to do some simulation. We are trying to figure out how the architectures like centralized architecture, federated, and decentralized architecture, how to evaluate this based on some key factors, so that we can have a comparison of these particular architectural alternatives, and we can provide some guidance to companies, like which particular architectural alternative will fit their business case and all those. And the key factors are mass customization, scalability, as well as model performance. So based on these 3 key factors, we are trying to evaluate the architectural alternatives. And looking forward to and expected deliverables, when we come to this, we are looking forward to study how MLOps is adopted in different SC companies, as well as based on the simulation, we are trying to figure out and trying to provide some guidance for AI model deployment based on the evaluation key factors also. And thank you. If you have any question, you can look into. You can definitely contact anyone of us. And if you want to learn more about my project, I'm happy to share my papers as well as. And we have a licentiate seminar coming on. So if you are interested and you want to have better understanding of my entire studies, you're always welcome to that. Yeah. Thank you.
Great. Thank you very much, Meenu. Let me see if there are some questions in the chat, or if there's anyone who wants to raise their hands. I'm sure you realize that you're the only thing between us and coffee, Meenu, which I suppose you are aware of. So that may not help your chances. But I'm going to give it a minute to see if there's anyone who wants to raise their hand. There's a long chat discussion in the chat, but that's referring to an earlier presentation, so not you. Good. To be honest, Meenu, I do not see any questions in the chat at the moment.
Yeah.
So what I think that we do is that, and we're out of time as well, I think that we leave it here, and I want to leave it here by thanking you very much for your presentation. I would like to thank all of the presenters for taking the time to present. The fact that I happen to be your PhD advisor or one of your PhD advisors had very little to do with you showing up, right? So I appreciate you doing that. That was intended to be a joke, but clearly, according to Meenu, not a very funny one. But I would like to thank all of you for presenting. I would like to thank the audience for participating and listening in. And as mentioned, feel free to reach out to me or to the PhD students directly if you have any specific questions about any of this.